Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 5 of lesson number 11, Work and Energy. Now if you remember, in part 4 we already started with energy and we even completed with like the work part, whatever information we had on work. We completed that in part 4, and then we started with respect to energy where we have even completed the introduction to energy part. So you know like what exactly energy means scientifically, right? And even we discussed on 2 3 different activities which were there based on work and energy both. So now as you know, in the further part there are like many activities and examples because we will be studying about kinetic energy, potential energy, conservation of energy. So these are the three different, you can say, three different subtopics which have been left. But in between, while we study kinetic energy, there are so many activities and examples given. Then when we study potential energy, again there are so many activities and examples given, right? So because of which the lesson becomes lengthy. Otherwise the concepts are very small, and even like when I have started teaching you this in part 1 where I have given you the introduction to the whole lesson, kinetic energy and potential energy, right? You might be clear with the derivation because I even showed you how can we derive the equation for kinetic energy, that is half mv square, right? So we are studying about so many things in the lesson, but as I tell you in every part that you need to revise each and everything. Okay, now as we are on to part 5, I want each one of you to please start revising everything that you have studied till part 4, and like whatever notes you have, first you need to go through them and then we can start with part 5. Okay. I hope every one of you are revising whatever notes you have taken in your book, because the notes that you're making is going to help you a lot at the end while you have your exam. So now I'm going to show you all the slides one by one, and I want each one of you to please go through them properly. Okay, so we have started the lesson by discussing on work, and over here we discussed on not much work in spite of working hard, right? So here we have so many examples, and we know how scientifically we can define work, right? So please go through this slide properly, everyone. I hope every one of you are going through it properly. After this, we discussed on this activity. So I want each one of you to please go through it quickly. I hope you are able to answer the questions which have been asked. After this activity 11.1, we discussed on the scientific conception of work, which is again very important, right? So I want you all to please go through it quickly. You need to go through the slide very well, and you should be able to know, like, you should be able to explain it as well, right? After this, we discussed on this activity 11.2. So I want you to please go through this as well. See, whatever question mark that you can see on screen, now you have to do your revision as such that you are able to explain that in detail. That is what is very important now, because you are revising it since two parts, right? So now you should be able to answer them all. That is what kind of revision I am expecting from you all. Okay, instead of like ratifying it or going through it, what you need to do is you need to explain the concept to yourself, and while you do so, you'll see that you will even gain more confident, you'll become more confident. Okay. Then we discussed on this activity 11.3. So I want you all to please go through it as well. After this activity, we discussed on work done by a constant force. So here we have the formula, the equation for force for work as well, where we have like work is equal to force into displacement. So force has been denoted as F and displacement as S. So we get the formula as F into S. I hope every one of you are going through this part. Then we discussed that work has only magnitude and no direction, and we need to focus on it because like this can be asked as objective either as fill in the blanks or as true or false, where like you will be able to explain if you are getting some statement as false, you have to correct that statement as well, right? So I want each one of you to please go through it as well quickly. Then we discussed on this example 11.1, and I want each one of you to please go through it as well. So here we have the proper explanation for it, and I want each one of you to please go through it quickly. I hope every one of you are going through this. Now I want you all to please go through this activity as well. Then we discussed on this example like how can we calculate the work done on a luggage, right? So I want you all to please go through it quickly. Sorry. Then after this example, we started discussing about energy in the last class, where we studied that what exactly energy is with respect to science, because as we studied that work has a different definition in science, right? Same way energy also has some different definition over here. And you need to notice, like you need to be very much clear with the fact that energy can neither be created nor be destroyed. We can only convert one form of energy to other. Okay, so make sure you know it as well. I hope you all are going through it. Now the main thing that we have about energy has been given over here. The SI unit for it, how can we define energy, what exactly energy is. Everything has been explained on the slide, and I want each one of you to please go through the slide very thoroughly, because you are doing the revision for this part for the first time, right? So you have to be thorough with this part. Then we discussed on this activity 11.5, right? So I want you all to please go through this activity, and whatever, like you might have written the question that they have asked. Okay. Then after this activity 11.5, we discussed on the forms of, like we need to discuss on the forms of energy that I'm going to start with today. Now if you remember, in part 1 also we have discussed them all, right? So we have different forms of energy, and the short form is given as ELTS. So we have electrical energy, we have light energy, thermal energy, sound energy, mechanical energy, and there are like many different energies altogether, right? So, luckily, the world we live in provides energy in many different forms. So, the world where we are living in is providing us with so many different energies, and all the energies are in different forms. Okay, so the various forms include mechanical energy. Now, always remember that mechanical energy includes two different types of energies in them. One is potential energy and the other one is kinetic energy. So various forms of energy, the first type of energy that we have is mechanical energy, and that includes potential energy and kinetic energy. Then after that we have heat energy, chemical energy, electrical energy, and light energy. So these are some of the forms of energy that we have. Okay, so I just want you all to take note of it, which are the different forms of energy present around us. Okay. I hope every one of you have written the different forms of energy. Now we have to discuss with respect to James Prescott Joule. Now, if you know, like you know this, right? If you know what, you know this thing that the SI unit for force is Newton meter square, or if you don't have to write Newton meter square, we can also write it as Joule, that is capital J, right? So James Prescott Joule was an outstanding British physicist. Who was he? He was an outstanding British physicist, and he is best known for his research in electricity and thermodynamics. So what he is known for? He is known for his research in electricity and thermodynamics. So amongst other things, he formulated a law for heating effect of electric current. For what he has formulated a law? For the heating effect of the electric current. So like one is he has done his research in electricity and thermodynamics. Apart from that, he has even formulated a law for the heating effect of electric current, and he even verified experimentally the law of conservation of energy and discovered the value of mechanical equivalent of heat. So it was not like James Prescott Joule was involved in only one work. Okay, now when you grow up, you will come to know that you have to do multitasking. That should be the thing that you should be very well versed with. Okay, now multitasking is also a kind of quality that you have. So James Prescott Joule, he was also a multitasker kind of thing. As you can see, he was doing his research in electricity, then thermodynamics, and he came up with the law on heating effect of electric current, right? Then he even verified experimentally the law of conservation of energy and discovered the value of mechanical equivalent of heat. So the unit of energy and work called joule is named after him. So because of the work that he has done, we have a unit of energy and work which has been named after him, that is joule, right? I hope you all are writing some of the points with respect to him in your book. Then after this we have kinetic energy to discuss. Uh, so I won't start with kinetic energy today because it's a huge part that we need to discuss, and like it will be very much for you. So I won't discuss about kinetic energy today, but I'll just give you like you can say an idea on what exactly kinetic energy is. Okay. See, we have already discussed the derivation for kinetic energy, so it's going to be easier for you now to come up with the, you can say, to come up with the derivation easily, right? So a moving object can do work. If the object is moving, if there is any kind of displacement that has been shown by an object, in that case we can say that a moving object can do work, and an object moving faster can do more work than an identical object moving relatively slow. So if the object is moving faster, it means it's doing more work, but if the object is moving slowly, then we can't say that the work done is more. The work done will be less in that case. Okay. So a moving bullet, blowing wind, rotating wheel, a speeding stone, they all can do work, and in all the cases they are moving faster, right? So how does a bullet pierce the target, or how does the wind moves the blades of a windmill? Or objects in motion possess energy. So if any of the object around you, if that object is in motion, it's going to possess energy, and this kind of energy we call it as kinetic energy. Okay, what do we call it as? We know it as kinetic energy. Okay everyone, so I hope you are clear till here. See, a falling coconut, a speeding car, a rolling stone, a flying aircraft, then flowing water, blowing wind, running athlete, they all possess energy. Why? Because the object is moving, and this movement can either be very fast or it can be slow, but the main condition over here is for kinetic energy that it should move. So all the examples that they have given over here, a falling coconut, a speeding car, a rolling stone, a flying aircraft, running athlete, they are all examples of kinetic energy. Okay. So in short, kinetic energy is the energy possessed by an object due to its motion. Okay, what is kinetic energy? Kinetic energy is the energy possessed by an object due to its motion. Okay, so kinetic energy of an object increases with its speed. How the kinetic energy will increase? It will increase with its speed, and how much energy is possessed by a moving body by virtue of its motion. So we know if it's moving very fast, it means it has more energy. If it's moving slow, it has less energy. So by definition we say that kinetic energy of a body moving with a certain velocity is equal to work done in to acquire that velocity, or it is equal to work done to acquire its velocity. Whatever velocity it is going to have, we are going to acquire that velocity. And let us now express the kinetic energy of an object in the form of an equation. So that equation I'm not going to start today. I'll be starting with the equation for kinetic energy because we have to study the derivation part as a whole, so I'll be doing that in the next part. Okay, But here we have so many examples and so many important information with respect to kinetic energy. I want you all to please go through it quickly. I hope every one of you are writing it. Now after this we have this derivation of the equation that I'm going to start with in the next class. Okay, then after this we'll be discussing on this activities which have been given for making us like aware properly about the kinetic energy. We have 4 to 5 different activities which have been explained over here. So we'll be going through the activities and the examples so that you are clear with each and every term with respect to kinetic energy. And after studying kinetic energy in detail, we have potential energy to discuss. So for that as well, we have activities and examples which have been given. We will be going through that as well. Then after that, as you can see, we have the activities, so many activities and examples. We'll be discussing on them. After that, we'll be discussing on potential energy of an object at a height. Okay. Then after that, we'll discuss on examples, and then we have the topic like, are various energy forms interconvertible? Can we interconvert those energy forms or not? So we'll be discussing on that. Then after that, we again have activity and law of conservation of energy to discuss in detail, where I told you that law of conservation of energy, whenever it comes to conservation of energy, we have the addition of kinetic and potential energy both, right? So after that, we have this activities, and then we have rate of doing work. We'll be discussing on that as well. Then again, we have activities which have been given, examples which have been given, and then we have like commercial unit of energy to discuss in detail. Okay, we'll discuss that as well. Then we have examples and activities, and then the summary discussion for the lesson, like what all we have studied so far. We will be like revising it over here, and after that we have like 21 exercise questions to discuss, which we will be discussing at the end of the lesson. So for now, I'm going to show you the slides one by one, and I want each one of you to please go through the questions thoroughly so that you are able to answer them all. Okay. I hope every one of you are going through it. So this is the last question that we will be discussing for the whole in the whole lesson, and this is how we will be ending up with the whole lesson work and energy. So make sure that whatever we have discussed in the whole lesson, you keep on revising it, because that is what is going to help you at the end. Okay, so I'll end this part over here, and I'll be starting with the derivation of the equation for kinetic energy in the next part, but make sure you revise all the previous parts. Thank you everyone.